Hello? Okay, good. Don't do that. All right, thank you all for coming to my talk. Today I'm going to be talking about the significance of an application networking platform in hybrid cloud and Kubernetes environments. I'm going to start off by talking a little bit about myself. I have been supporting development and operation teams for over 14 years now. I got my start doing broke fix for small businesses out over in Delaware. Really, I got my career started when I was hired to build a Windows network for an organization that had nothing but Linux admins. So it was a real weird experience. Yeah, I see some faces. They're like, what? Yes. It was a weird project that they had. They had no expertise. So I got hired to build their Windows network. So they introduced me to Linux a little more deeply than I had used in the past. I would play with it here and there. Started out with Red Hat 8, so back in circa 2000. And so like most of that, I started out building bash scripts and automation, kind of looking at virtualization to play with it some more. I really got started in like the cloud kind of technologies around when Docker was about 01, 03, somewhere thereabouts. So we're talking about when, in order to build a Docker container, you actually had to package everything up in a tarball. So you had to extract all the binaries. Yeah, you're laughing. I see. You remember those days. So yes, that's when I got started into the cloud and doing a lot of those kinds of things. Eventually, I was hired to just go out and deploy Linux servers all over the world. That was where the interesting and the fun skill building came in. Currently, I'm a solutions architect at Gray Matter IO, where I support customers. I help make the company's product better, i.e. I find their bugs and tell them about it. And train and build up internal teams so that they have an understanding of what different technologies do. In 2018, I applied and became accepted as a subject matter expert to help develop the CompTIA Linux Plus exam. So this was the time they said, yeah, we're done with LPI. We want to roll our own thing. So I helped build the 04 and 05 exams, come up with some of the, hey, this is what we're seeing in the industry kind of stuff. And then a lot of questions for those exams. So before I get into the meat and potatoes of my talk, I'm going to take you on a little adventure through time. But when we started out building and wanting a new application, right, we'd have to go to an infrastructure team and get a new server, right? They'd order it, they'd purchase it, it would be provisioned with all the security policies in place. So in a previous company, we were able to shave some of that time down by actually having a stockpile of servers. Not everyone was that lucky though, right? So It still took a couple days because you had to pull it out, rack it, configure all the disks, make sure that they were in the right arrays, and then kick off the automation system. Well, like I said, it took a couple days. Then you had to box it back up and ship it out. So after service provision, racked, IP'd, and all that stuff, now you got to wait for the ops team or whoever you had installing the software. And sometimes it went off without a hitch, but not always, right? Sometimes you would have to go back to the developer and go, yeah, it didn't install. And they were like, did you install this package? And we're like, that wasn't in our run book, no. So we have to go back and install the package. Or, hey, it's stack traces. And they go, what version did you pull? I'm like, the one you just gave me. And they're like, that doesn't sound right. And I'm like, oh, it's right. Here's the stack trace. So I stopped going to them and just started like, okay, let's look at what's going on, analyze that. Took those couple of hours and then went back and like, yeah, you need to update your stuff. This is not quite right. But now we're not doing that, right? Those days are almost over. Now, some people are still running that kind of process, and it baffles my mind. But with those days almost over, magic almost, right? The couple of commands and some automation scripts, you can deploy a new system in minutes, hours if you're using the free version of Circle CI, but or your Jenkins server is really underperforming. But security teams can pre-stage VMs with appropriate patch sets, securities in places, and everything, and it's just a flip of the switch. So then development and ops can work together to make sure that the application, when it's deployed, runs properly with these pre-staged VMs or containers. Right? With the speed in which the cloud and container environments are moving, we need to ensure that the communications between the microservice architectures are actually secured. Not only do they need to be secured, but we need to be able to do things with those without human intervention. Right? We can't be going and updating a ton of ephemeral IPs, because in every cloud instance, your IP is 10 dot something or 172 dot something, right? So, I don't know how many times in my career I've had to go and change and update 25 IPs across multiple servers because someone chose to move my VLAN over one, and that changed the entire subnet that I was in, which means my entire IP range changed. So this is where an application networking platform comes in. First I want to address the difference between application networking and an application networking platform. Application networking is only the interconnections between services, APIs, and the applications themselves. Whereas an application networking platform, while it's a relatively newer term, the definition is still hazy, but it's starting to sift itself out. I'm going to tell you my interpretation of the stack is. So it is a suite of tools that enables communication between APIs, endpoints, services, databases, whatever you have in your application, and it builds those interconnections between all of the objects. And by doing so, it's adding a layer of security onto your network in itself. Right? It's going to facilitate the development and deployment and management of the application network itself, allowing you to move from dev to test to prod more rapidly and repeatably. What it is not, though, is not just a networking app. It's not just a tool for networking. Right? It is not just a service mesh. Right? And it's not just a feature that can be turned on inside of Azure or Google or AWS. So what are some of the things that it provides? It is going to have a service mesh because that is one of the most easy and effective ways to handle the communications and interconnections between the APIs, the applications, and the services. It's going to have a control plane. That control plane is going to do things like service discovery and then provide each application and service the structure in which it should be performing, the connections it should be talking to. It's going to add a layer of security onto the network like like Zero Trust. It's also going to provide you a way to define your networking as code. So you already have your infrastructure as code in Terraform or CloudFormations or whatever Azure has going for it these days. And this is going to be supplemental to it. Like you have your Terraform to deploy the infrastructure, and you may have your Ansible to configure the inner workings. This is actually going to be used to define how you are interconnecting all of your applications. You're going to use GitOps to apply these changes repeatably over and over and over again. You're going to use GitOps with this because it's the best way for you to track who's doing what changes are they actually making, and then, well, ultimately, who allowed those changes to get into main, right? I mean, if you do not lock down your main branch, then any junior developer is going to be able to push code directly into that, and then you're going to have to revert back. Now, while you have this always running GitOps model, and when the junior developer does unintentionally push something to main, rolling it back will fix it just as quickly as it was broken. Another feature of leveraging the GitOps is you have a source of truth, and you're going to have a way in which you can help to prevent configuration drift. Right? And I say that because as a systems administrator for a very long time, I would log on to a server only to find out that someone had turned off IP tables or made changes to things and didn't tell anyone about that. Right? Never happens, right? So what does it do? So there are basically four things that an application networking platform does. The first is it's going to provide you the ability to control the aspects of what is going on inside of your application network. It's going to tell you what's on the network. It's going to tell the workers what to do when scaling occurs. It's going to manage the interconnected traffic, so who's talking to who. And it's going to ensure all of these things are in fact connected. And then it's going to collect a lot of data off of those interactions. This is more of the brain of the operation. So second thing is it's going to secure the interconnections and communications between all of these services. So what's talking to what, and is it secure? Who is talking to the connected services, like specifically users? Ensuring that I had a tongue twister here. Ensuring the proper policies are actually being enforced that have been set forth. So, I mean, this is going to be one of the primary tools and goals for your security teams to ensure that you're starting to follow some of these better processes. And this section kind of is the enforcement engine, so it kind of makes the CISOs happy, if you can actually make them happy. The third thing is it's going to give you the ability to visualize and see statuses. So see what's going on the network. What services are down? Are there latencies? Are you having connectivity issues? Maybe when you're jumping across clouds, there's a high latency, or I don't know, Amazon's down. Never happens. But it'll give you the ability to see everything. Right? Now, all of these steps are actually going to be collecting data inside of your platform, and it's going to provide some insights into what is actually going on inside of your application network. So you're going to be able to see what's going on, who's connecting in, and the ability to feed back that data to your software development lifecycle teams, the security teams, or if there are anomalous trends, and then information that you have also gained can be passed back to management for various decision makings that may actually occur as a result. So I'm going to go a little deeper into the core elements of control. There are 3 of them. The first is service discovery. So I've spent a lot of time commuting in my career, a lot of time. And there are always 2 podcasts that I listen to. One is a Linux-based podcast, and the other one are various security podcasts. The common thing that I hear in security is you need to know what is in your environment, right? So this is where the service discovery comes in. It's going to go out and it's going to find all of the services that you have in your environment. So Kubernetes or AWS, and it's going to start collecting information on those. So it's going to find out what the service is and how many are there. Right? When you know how many services of something, that information can be very helpful as we start to scale. As we start to scale, we look at the network. We're going to go back to the networking as code comment I made earlier. One piece of networking as code is going to scale across all of these applications and services because they're all the same at the end of the day. When you turn your auto scaling group on for a service or an API that you're leveraging, it's going to have the same configurations always. But what's going to end up happening is the control plane is going to go out and it's going to get all of those IP addresses. So that when I have 3 front ends and I have 5 back ends, all of the front ends know about all of the 5 back ends. So this can ensure that your traffic is maintained throughout the network. Now, I have my 3 front ends and I have my 3 back ends. Now we can start to do some traffic management around that. So how do I want to do that? Do I want to do round robin? Do I want to have it weighted, right? Maybe I want to use what the best response time is. In a scenario where you're in multiple clouds, you have Azure, Google, and AWS for diversification to kind of keep your costs down because, hey, maybe Amazon has the better GPUs. I don't know. I don't know what your applications are going to do. But if they aren't scaling well or you're having problems because of intermittent latency, maybe that's not the best response time and you have to shift traffic. This is what's going to help that. And when you start to implement those things, it's actually going to give you a performance increase. Now, while it's probably milliseconds, right, that's still a lot of time. Traffic shaping has a bunch of different options inside of an application network, right? You can use this to start testing out blue-green deployments, right? Because of the control plane and how you have everything configured, your load balancers can send all the data to your blue deployment and your green deployment, and you can start shaping that traffic as you see fit. Maybe it's not working out. One of the other nice features inside of the traffic shaping is maybe you have a brand new service that you want to push out there and it's going to potentially break something, but you're not aware. Looked good in testing, but you're still just a little not sure. You can shadow the traffic, right? So you can send that traffic to that extra service just in case to see what happens. Maybe you did break a API and didn't even realize it. And when that traffic hits there, it's only shadowed, so it's not going back to the customer, so the customer's never going to see it. But you're going to be able to see what's going on in those logs. What happened to that application when someone did that GET request? Right. So the next thing I'm going to talk about is the security elements. So again, 3 elements inside of here. The first we're going to talk about is network security. A lot of organizations are starting to they're going to start to be required to move to zero trust kind of capabilities. The federal government has already mandated it, and they have a certain amount of time to start following the NIST 800-207. So what all the government agencies are doing is they're taking that NIST guidance and they're making their own flavor, but they're still following the heart of it. PCI DSS and HIPAA are fast on the heels for that as well. I mean, HIPAA, I'd hope they start doing that because we don't want customer or patient data just flying around a network in between applications. So the network security is going to provide the zero trust between everything. So for those of you who are not aware of what zero trust is, it is don't trust anything unless there's a mechanism in place for you to trust it. I sum it up a little bit. There's larger definitions, obviously, on the internet. But this is where you're starting to use TLS, or even better, you have mutual TLS, right? I like to, when I talk to people about this, Bob and Alice, right? That's basically what we're talking about here is the whole PKI, cert, key, trusted CA. If I don't trust your cert because I don't have, or if I don't trust your cert because I don't trust your CA, then you're not getting through. Right? Certificate rotation has been a problem for me in the past, and that's when I kind of found this open source project called Spiffy Spire, and it helps with certificate rotation. So it'll automatically generate your certificates every so often. So as it does that, you get a new cert minted every, let's call it hour or less, right? You define all of those things. So that helps with the rotation of those certificates. You really can't get around too much of the SSL side of the house when you're actually doing on like websites and stuff like that, but tools like Let's Encrypt provide you some kind of mechanism to do the customer facing. But as far as service to service is concerned, that's where you want to start looking for that. So I'm going to talk about access control now, and this is where the security elements come into. You need to be able to limit which services talk to which other services. Now, I like to use the front-end, back-end database kind of example. In your new Web 3.0, front end, you have a back end that does all of your business logic, and then you have a database that you're storing whatever it is, your shop, right? Your whatever it is. So when your front end goes to talk to your back end, that's fine. But when your front end goes to talk to your database, well, why is it doing that? That's what you built the back end for, right? You specifically set these up so that they don't have to anymore, right? That's not where you put the business logic. So when you put the business logic in a place where you need it to be, you can limit what can access each other. So my front end doesn't talk to my database, no one else can talk to my database, and no one else can talk to my API or my backend endpoints, unless I'm so kind as to let them leverage some of the hard work that I've already done, right? So you can specify those minor details, right? Integration with some kind of identity management solution is also a part of this, right? We need to be able to see what users are logging in with, right? This can be, your custom, whatever you guys are running in the back end. It could be like a Keycloak instance or something along those lines. But you're going to need to be able to see who's accessing what and what they're accessing so that you can start to make informed decisions later on in the process, right? Once you have this user information, you can start to do things with it, like sending it to some kind of policy engine, right? So when we talk about our policy engines, right, we have the user, we have what they're trying to access, and now we can start to integrate RBAC and ABAC rules directly into the application network. Now, while RBAC and ABAC are great. There are better options out there. I have leveraged OPA, which is the Open Policy Agent, to do very similar things. If you're not familiar with OPA, it is all of your it's a server that sits on your network, and all of your configurations and all of your policies are written in something called Rego, and that looks like just a bunch of regular expressions. So if you really are into regular expressions, that's the thing for you. But in testing out some of what can be done with OPA with Rego and with ABAC and RBAC policies, I think I wrote about 100 lines worth of RBAC policies that I could basically do with 10. So again, it's regular expressions, so you have to kind of read regular expressions in order to understand it, but I mean, that's a lot of lines of code that people don't necessarily have to go through, but you have to, understand what's going on there. A developer I've worked with, he actually used Rego in one of his projects to actually do a lot of the business logic because of how powerful it is, and to secure the application that way. Yes. He's a masochist, I believe, but he's a great guy. So ops and insights, I kind of put hand in hand. Being able to visualize what you see on the network is a very important key. So what do ops people need, right? They need to see what's up, they need to see what's down, latencies, outages. Hey, are pods bouncing up and down? Are they experiencing other sorts of outages that maybe aren't even relevant to your environment? But they can also see who's trying to connect. Right? They can see which services are going to connect to which other services. Like, I would have loved to have had something like this when I had my 25 servers all over the world, but the best I had was Nagios. And in order to actually see any of that, I had to port forward SSH to actually do anything with that, and that was a fun day. I think Grafana might have been out at the time, but there wasn't really good visualization tools for it. I mean, things have come a long way since I've been doing that. So now that we've collected all of this information and we have all this information available to us, right, we can start to make informed decisions about our environment, right? We can look at performance issues. Hey, have we hit resource limits? Are we not scaling appropriately? Right? Does something need to be refactored? Maybe we need to address how many nodes we have in our Kubernetes environment because it's just not enough as we scale up. Maybe we need to go the opposite direction, and we can save a couple $1,000s a month by going down to a significantly less amount of Kubernetes nodes because we're not actually utilizing any of those. These are just some of the things that you can start to glean out of those, that data and that information, right? Maybe if you notice a lot of latency in your applications, and let's say you're in a AWS auto-scaling environment, you see that, hey, when peak times come and we see the auto-scaling go up, we're still seeing latency and we don't understand why. It's like, well, maybe that VM is still trying to come up and you're not actually able to hit any of it. And so it's not actually being useful to you. So maybe you need to have two. Maybe you need to re-architect that entire thing. Maybe you need more smaller ones. Like, these are informations that you can kind of glean off of that to help you make informed business decisions. Next thing we want to look at is usage. Who's accessing APIs? What routes are they trying to access? Right? What are all these users trying to do? Can I say, hey, this API hasn't been touched in a month or a year. Why do we still have the pod running? Should we deprecate it? Right? Or, hey, we're getting a lot of 404s on this particular pod. Maybe we should start, open a bug and try to figure out what's going on there. Right? But then you can start to see user anomalies as things go on, right? What is happening on your application, in your applications outside of normal business hours, maybe? Why is my CEO trying to access an endpoint and do put requests at 2 a.m.? That doesn't seem right? Or, hey, this URL has a select statement in it. I don't understand. Like, what is select admin from password going through a URL for? That's weird. But you can take that information. You can open up tickets with developers because you have all this information at your fingertips. You can see these things. You go, hey, someone's trying to do SQL injection. Maybe we should double check to make sure we're secured against that. Or even better, because you're using this, let's update our OPA policy or our RBAC to specifically block anything that looks like select star from in our rules. So what are some of the benefits? So overall, you're going to get some standardization, right? You have one basic code base to move your application networking platform and the application networks through dev, test, and production, right? There may be some minor changes if you're doing some, funny stuff with it, but you'll be able to move through quickly and efficiently and make sure it's stable all the way through, because this is actually what you have here is basically what you have there. We talk about some of the benefits to the people, right? More bug fixes, more feature implementation, more deployments, faster time to resolution. And your infrastructure is going to, potentially need to be reevaluated. I'm not saying it does. You may have spec'd it out perfectly the first time, but it might. Maybe we can use smaller pods. Maybe we can assign less overhead for memory and CPU for our Kubernetes environments. But the biggest thing is, hey, this is not actually a part of any specific cloud provider. So I can take all of this information and all of this configurations and move it to someone else. Right? I don't have to be locked into AWS. I don't have to be locked into Google. Maybe I like to be locked into Google, but I don't have to be. I can find the best prices for whatever services and applications, cluster sizes that I need. Maybe you're tired of having a hosted Kubernetes and you want to self-host. It gives you the ability to kind of identify some of those things. So what are the benefits to the teams? So developers can focus on the features and not the implementation details of what is going on inside of your application network, right? New business requirements come up all the time, right? Hey, we're going to this new IDM. Well, the developers don't really have to worry about it, right? Because they're already taking care of that. Or, hey, we need more user information in our log messages so that we can pull it out and use it in Elasticsearch. But security says you can't use log4j because that's not good, right? But they can also just assume that the connections that they need to have are there. And they don't really need to know how many they're going to be. They just need to know, I need to hit this port and run this query, or this port and make this call. And that's it. Because your underlying infrastructure is taking care of all of that. It knows how many back ends you have, it knows how many front ends you have, it knows how many databases you have the ability to connect to. The benefits to the ops team, they ensure that everything's functional, right? Like they have the dashboard, they have metrics reporting. When someone, I don't know how many times people have come like, oh yeah, well how many users did we have last month? And you go, I don't know, hold on, let me go look. And you gotta run a report, it's some weird, JSON query because you're using Elasticsearch as your back end, right? This is all captured, right? They can also maintain uptime. When you're talking to them, if they're having issues, it's like, hey, what's going on. Well, maybe they have in their run book how to fix this particular bug or this particular problem, and maybe they don't. But if they see who's having, what services or what applications are having this particular problem, they'll be able to call in the right people and not call in the database administrator when your front end's not working properly, or calling in the systems administrator when it's the DBA's problem, right? And they don't have to worry about configuration drift. They don't have to worry about, oh, hey, did someone do something? Did someone actually change something and not tell us? Let's look in Git. No changes have been made. Okay, so it's not a configuration issue because we know it's the same every single time in every single pod, container, or VM. And security gets a peace of mind that says, hey, I know we're secured and I can prove it. We have zero trust between all of our services. I am blocking these kinds of attacks with our policy engines, and I know they're being enforced because I've seen the code that actually puts them in force, that enforces that stuff. So some closing remarks. So an application networking platform will end up leading you to faster development, deployment, and increased stability inside of your networks. So a little story time with Jim. I was talking to a buddy of mine, and I know he's gonna have to start doing this. He's running a service or a server with a bunch of different applications running on it, and lots of them all over the place. And I asked him, I know zero trust is going to be mandated for him specifically, and I'm like, hey, how are you going to do that? And he goes, oh, we can use PKI. And I'm like, all right, well, who's writing the code for that? Is it the engineers or the developers? And he didn't really know. He's like, well, we're going to have to. And I'm like, okay, well, that's great. Well, what happens when the certificates expire? Who's maintaining the knowledge of that? Who's maintaining all of these interconnections that you have, because everything in your all of your servers are connected? He didn't really have a good answer for me. I'm like, okay, that's fine. I'm like, well, how are you establishing what services can talk to what services inside of your box? And he goes, well, we can use firewall D or IP tables. And I'm like, okay, well, all of your field engineers have sudo on that box. What happens when they just turn it off? And he's like, oh crap, I forgot about those guys. I'm like, yeah, most people do. So, and then I asked him, I'm like, all right, so what happens when they want to move to the cloud? And he's like, yeah, I don't think we can with our current setup. And I'm like, no, you have nothing to protect your services. You have nothing to protect your system, right? It's just not going to be possible. So that is my talk for the day. I appreciate your time. Thank you very much. Any questions? I'm here to answer them. Yeah, he's got the microphone.
Sorry. There was a previous talk about running things kind of all internal, having a Docker call out and go get the script that it's going to run for some monitoring of things. With this zero trust, you're saying you'd have to do some things to find out whether that script is signed and those signatures and that kind of thing. What software is it that's available for that in these layers?
So if you're talking about exiting the service to connect to another service to pull in those containers, that sounds like it's done before you're actually deploying your application, or is it done post-application? I missed the talk, I'm sorry.
The talk was about monitoring things and having some containers inside the container, the script to do the monitoring, that all the commands were outside of the definition of the container. Someone asked a question, well, how do you know that script isn't malicious? You've kind of shown some things. There was some other discussion, some side discussion. It's like, well, it's all kind of sort of all together.
Yeah, so at that point, what you would do for that external connection out, you would want to have something like you would want to have the PKI on the receiving side as well, right? So whatever's receiving your whatever you're pulling your script from, you would want to establish that connection as a trusted connection.
And
So it could be TLS. It doesn't necessarily have to be mTLS, but it should be. But I don't know if there's a use case that I've seen where that's a thing yet. Sounds awesome though.
thanks.
Hey, Jim, be sure you repeat the question back so we get
Oh.
the video, okay?
Yes. Sorry. Does it not go through on the microphone? Okay. All right.
Definitely comes through much clearer.
All right. Thank you.
Repeat it back so we make sure we get it.
Will do.
Hey, thank you for the talk. Just for some context, at my job, we use Terraform for our infrastructure as code. And for a while, what we were doing is we were using OPA for our scans. I'm not sure if you've heard of KICS, keeping infrastructures
I have.
secure. It's basically just an open source repository where people have been creating those scans for cloud infrastructure, all different kinds of cloud platforms. Right now, we're using TFE, Terraform Enterprise,
Okay.
and we are writing Sentinel policies. And I was just wondering, do you know of any like other scanning platforms? Because we seem to be limited by the by what like OPA can do. I didn't know if there was any other alternatives that you might be aware of.
So you're talking about scanning the pod for vulnerabilities and issues?
Yeah, just scanning the code. And the way that Terraform Enterprise works, are you familiar with Terraform at all?
I'm fairly familiar with Terraform. Yeah, I've used it to deploy some services here and there.
Gotcha. So what the open policy agent does, at least with KICS, is that it just turns the code into JSON,
Okay.
and it does it like line by line, but there are limitations that I'm not going to get into. But the way that it works with Terraform Enterprise is that a mock is generated, and that basically shows all of the resources that are going to be deployed. And it seems to be the best way to go with Terraform Enterprise, or with Terraform in general. I didn't know if you were aware of any other solutions for that.
I haven't heard of any other solutions like that. I know Sync sends me stuff about like scanning, how they can scan containers and stuff like that. And I know some organizations that I've dealt with have other things, but that's like after they've been uploaded into like Artifactory and stuff. I want to say twist lock, but if that's what you're talking about, like looking for vulnerabilities, that's about the only things I've heard of.
Okay. Thank you.
Yeah.
So an application networking platform, do you think of that more as a concrete set of software, or is it more an approach?
Well, as of right now, since okay, sorry, your question is the application network platform a concrete solution, or is it,
Or is it more
Or is
of
an approach?
Yeah.
Because it's relatively new to the industry, I know that there are some vendors who have latched onto it. I want to say that it's a suite of software, but I think it's one of those things that's still developing. It's still early days in the whole concept of it. I know that, and I didn't want to say this here, but Gartner has been making mention of it every so often as a thing, but not sure where all this is going to fall in the next, 3 or 4 years now.
Okay, yeah, because some of these features I get in Kubernetes, like the ability to control which services talk to which ones, but not all of it. Some of this stuff, I'm not sure how I would do it.
Yeah. You can do a lot of the stuff with Kubernetes services and load balancing and things like that, but at the end of the day, like how do you get information back out of some of that stuff? And that's where the entire platform comes together and takes all that information and actually bundles it so that you can actually do something with it. And it's not just, yeah, well, it's a security policy. It's more than just that. Any other questions? All right. I appreciate your time. Thank you very much, and I hope you all have a great day.